I think it should be fine to start the episode now. Um, so first of all, I'd like to thank you all for attending. I would like to welcome you all to our second episode of our season 2 of the Loops webinar. Loops is a live webinar series that focuses on highlighting the innovation produced by Horizon 2020 funded projects in the field of social innovation and circular economy. I am Robert Buchan. I'm a communications assistant at FELTA, and the topic we will be discussing today is the mining industry. And to help with this discussion today, we have invited from ROBOMINERS project, Claudio Rossi, and from the Diga project, Emil Alrich. So again, thank you all for attending. And to start off the webinar, I would like the guests to introduce themselves. Whoever would like to go first.
Okay, I'm Amal Alrich. I have graduated recently as a PhD in telecommunication engineering in Italy. I'm working with Rotec. It's one partner in this project, in Digit project. And yeah, thank you very much, Robert, for this opportunity of presenting our project.
Okay, thank you. Thank you, Robert, for the kind invitation. My name is Claudio Rossi. I'm a professor here at the Technical University of Madrid in Spain. I'm working at the Center for Robotics and Automation, and I'm the coordinator of the ROBOMINERS project.
Great. So just to give a quick rundown of what the webinar consists of. So we will have a presentation from both the projects showcasing their work, and then we'll have a short Q&A at the end, near the end of the webinar. So if you'd like to ask a question, ask on the YouTube chat, or if you want to go to the event page, chat on LinkedIn, and make sure your questions are answered. So Emil, would you like to go first?
Yeah.
Sure.
I'm gonna share my screen. Okay. Can you see the presentation mode?
Yeah, it's all there.
Okay, so before starting, I would like also to say that I work on the task of dissemination in this project. Our project is called Digit. It's a human-centered Internet of Things platform for the sustainable digital mines of the future. The project duration is for 4 years. The project coordinator is Maria Garcia Campurpi from Itanova, Spain, and the technical manager is David De Paz from Subterra. So at the beginning, I'd like to introduce who are we. We are 16 partners from several countries in Europe and even outside Europe. We have 10 work packages. Several tasks and deliverables will be delivered during the project. And in order to validate our solution, we're gonna validate it through 5 use cases, which are mines around Europe. So we are the partners are Itanova, Core Innovation, Brunel, Tau, Rotec, ICCS, Subterra, Stratagem, Eurocore, Libra, Marini, Tapo, Centef, Titania, Say, and IOTA. And the countries involved are Spain, Italy, Greece, Cyprus, Germany, Belgium, Finland, United Kingdom, and Norway. So what is the concept of this, like the general concept of this project? Now, we want to gather data and we will develop the IoT platform and analyze this data and see what is interesting for us. And then the output will be illustrated via the interactive decision support system, DSS. So as we see, the idea is general and can be applicable to any sector in the industry. And for us, we're applying it in the mining industry sector. Now, starting from the data, we know that big data is very trendy nowadays, and it's not about having a lot of data. It's about having coherent data. In order to do that, we want to know very well all the mine's challenges and problems and we want to investigate these problems and to see which variables we want to measure and how we should measure it in order to see what is interesting, like the data interesting for us. So we're going to gather data from several levels at the beginning, the people level, people who are working on the mines. We're going to develop a smart garment in order to get these the parameters, the occupational health and safety and environment parameters, and we're gonna monitor the assets, machines, vehicles, and tools, we're gonna also get environment variables from the environment, whether from the workplace, temperature, gases, etc. Or from the ground to see the structural and seismic stabilities of the ground of the inside the mines. And finally, we consider the market data, so the demand and commodity prices. To measure this data together with the platform. The second thing is the IoT platform. It's basically a software. Or like to say it better, it's a bunch of softwares and new technologies. At the top of that, the digital twins. We're going to develop digital twins on several levels. First, the operation and maintenance. We're going to develop the digital twins at the soil level to study the geotechnical risks. And also we develop the digital twin to model the fluid dynamics process involved in the mine operation. With these models, we will do the health and environmental real-time risk maps. The second technology is, of course, we will analyze this data coming from the sensors inside the mines. We're going to have also a smart scheduling tool to optimize to optimize the planning of the mining operations. And we're going to have the predictive maintenance agent and predictive operation agents, and all of them are oriented to process the data we're gathering from the mine and to see what is to act on it, add value to that, and analyze it, and to see what is interesting for us. And at the end, all of these technologies, data and communication and output will be illustrated via the interactive decision support system and via smart dashboard to show the operation variables, environment, and all of these data we got from the mine. Now, this is roughly speaking the concept of our project, but in order to link all of this data and communication technologies together, we need to aggregate the data. So we need an aggregator in order to link these technologies and the data. And also we need to have on top of that cybersecurity layer, because some of the data that we're getting might be confidential and we don't want anyone to alert this data. And at the end, the end user will have this DSS available and they will check all the parameters from the mines to optimize the processes and to manage the operations in the mines. And in addition, we will develop a blockchain, and we will implement the distributed ledger technology to open some data to the world. Now, our motivations and expected impact is very are very promising. So, and it tackles many aspects. For example, for the company, we expect to increase the efficiency and the overall equipment efficiency by 18%, and we will increase the efficiency of the mining by 17%. These are like expected impact, and the main focus of Digit project is on the safety of the workers. So probably we might increase the job opportunities, whether people working inside the mines or people even working on the platforms, the IoT platform. We're going to increase the return of investment. The expected value is 28 million euros for the consortium, and of course we're going to decrease the emission of the CO2, and the expected value is 19%. We will decrease also the waste and the water consumption, and also using the blockchain, the community will trust this data. Now, in order to validate this platform, 5 different use cases will be operating and will be use cases to test and validate our solutions. And given the complexity of the mining activity in general, involving numerous types, different challenges. So these 5 use cases imposed different challenges regarding, for example, the mining environment, whether it's underground or open pit, or like mining life cycle stages overall. The beginning. The first use case is MARINI MARMI from Italy, north of Italy, near Bergamo. It's an underground quarry. It's for extraction of exclusive stones, Cipo Grey and Novolate Grey. And since it's an underground, so the most challenging environment in the underground quarry is that there is no connectivity for the workers. So the underground air quality is an issue. The noise level is an issue, and also the unplanned downtime for the equipment, and of course raw materials will result in waste. So how Digit addresses these needs? Digit predictive operation aims to address waste reduction and reduce the unexpected unplanned downtime. And predictive maintenance agent for critical equipment will lead to significant reduction in cost and planned downtime reduction also. The Digit environment and health safety online monitoring with Smart Garmin will provide cross-validation for workplace parameters, monitoring the air, gas to assess the underground air quality. And also Digit Twins for fluid dynamics will provide real-time risk maps. The second one is La PARRILLA in Spain. It's operated by W Resources and Subterra, and it's an open pit for tungsten material. And since it's reopened in 2018, and it's an open pit. So there is like the main challenges for this mine is lack of maintenance and surveillance during the closure time, which add uncertainties to over the initial mechanical behavior of the pit slopes, and the overall slope angle is an issue also, because lower angles lead to large waste and large land occupation, and at the same time, or on the other hand, these lower angle they will lead to a lower to higher safety factors for the slope stability. And how Digit addresses the needs, they will we will use the geotechnical digital twin component to optimize the geotechnical monitoring system, and we will monitor the main parameters of the slope behaviors by, for example, sensors put on the rock faces and the dam walls, for example. And we will provide the framework for decision making based on the mine requirements, and all of these will be integrated in one platform, which is our platform, IoT platform. The third one in Norway, it's for it's an open pit, and it's for ilmenites material. And this open pit is or this mine has many challenges regarding the water discharge monitoring, the slope stability, of course the safety and the equipment security. Since it's an open pit, so they share almost the same, or like they have some commonalities with the La Parrilla, and they have also sustainable production. Sustainable continuation is an issue. The overall operation monitoring and scheduling is an issue, and how they address how we address the needs. First, we will develop, as in Parrilla, we will develop the environment and health safety online monitoring, and we will employ the sustainability methods. As in La Parrilla, we will employ the technical digital twins to simplify the stability monitoring for the slope stability, and we will assess the feasibility of implementation of predictive operation maintenance and agent in order to reduce the operation risks. And through the smart scheduling component, a set of parameters, water, energy, or waste will be analyzed and integrated to the DSS, improving the overall mine performance. Now, the fourth one is in Finland. Tapo is operating these two use cases, one underground for which is called Sotkamo, and for extracting silver. And they share almost the same challenges, like the safety is an issue, the hazardous conditions at the charging and loading areas is an issue, changing rock conditions and traffic and unhealthy gases inside the mines also, which affect the safety of the workers inside the mines. And the Digit will address, we will address these needs by predictive operation, predictive maintenance, as we said, and via the environment and health safety online monitoring. And all of these new technologies, of course, we will be integrated inside our platform. And the last one is an open pit mine, and it's operated by the same company, Tapo. It's called HANNUKAINEN for iron, copper, and gold concentrate. And the lack of digitalization here in this mine is the main challenge and need for that. And so Digit will focus on the increasing the digitalization and occupational environmental monitoring and health safety monitoring. Providing the info flow for the local by integrating the environment compliance to facilitate the communication local stakeholders. They will also we will develop this EHS, as I said, and the methodology for this test and the sustainability compliance labeling will be envisioned online, and this SCL will ensure the trustworthy resource monitoring, and we are planning to encourage participation of local stakeholders, of course, with the blockchain, so the community will trust this data. And that's all from my side. Thanks for your attention. And these are the social media accounts and our website. And these are the emails for the project coordinator and the technical manager. Thank you.
Thank you for that. That was great. That was perfect. Claudio, if you'd like to go now.
Yeah, ready. Let me share my screen. Okay. Do you see the presentation? Hello?
Oh, yeah, it's on the screen.
Okay, perfect. So, good morning, everybody, again. So, I will talk to you about ROBOMINERS, which is a H2020 project, and it's about resilient bio-inspired modular robotic miners. So it's much more heavy duty than what we have seen with Digit. So as everybody knows, Europe is largely dependent on the import of raw materials from abroad, in particular metals and minerals, up to 100% of some critical commodities. So there's a growing concern to provide means for providing Europe with raw materials from domestic supply, or not depending on importations. So, in ROBOMINERS respond to a call of the EU to find new ways to reopen old mines, or to anyway extract materials from domestic sources. Oops. Okay, so a little bit more about the project. So this is the core topics: a new solution for sustainable production of raw materials. It's a research and innovation project. So it's very low TRL, if you know what it means. The technical readiness level is very low. It's a research project. It's going to be 48 months. My university is the coordinator, but we have 14 partners from 11 countries. So we have geoscientific SMAs like La Palma, Diamonte, QTech, and RCI. We have academics, of course, universities to do the research, both on mining, like Mountain University Leuven or University of Miskolc in Hungary, and the robotics part, like UPM, Tallinn Technical Institute, and Tampere University. We also have non-governmental and governmental institution on board. So the concept is to design a robot which is modular, so it can be assembled in place. So in this case, we access the mining site, sending the parts down the borehole or down any other access to the mine. The robot should self-assemble to form a fully functional robot. And then the robot will be equipped with specialized sensing devices to detect the ore and to decide where, in which direction to dig. And also using this some ad hoc production devices that we are studying, they will produce a slurry that is pumped out then with classical technology out of the mine. Okay. One feature of the robots is that they can reconfigure on the job. So if there's some kind of failure or some kind of special need, the modules can change. The robots can change shape to a certain extent to cope with the unforeseen situation. Okay. So the kind of the
Sorry, Claudio. Sorry
Yes?
to interrupt. Your presentations aren't changing. It's still on the first page.
Oops. Which page are you seeing?
We're just seeing the
First one.
Yeah,
The first one.
And it's not in presentation mode for me.
Yeah.
Okay. Oh, okay. Let me try to something else. Let me stop. Let me share something else. Oh. I'm sure. Okay. What about now?
Yeah.
Okay, so I was here basically. Sorry.
I know, it's fine.
So this modular robot can reconfigure on the job because of its modularity. So the kind of the targeted mines are basically three big classes. So we have abandoned mines, medieval mines or historical mines that now are mainly flooded. So the idea is that these kind of sites can be reopened without the need of the watering. Actually, water will be an advantage for us. So this is the first kind of target scenario where we foresee to use the system. Then we have small but high-grade mineral deposits. So since the robot it will be relatively small, we can do precise mining, small in the size of the mining scales. Okay, so we can do precise mining, so we can take advantage of relatively small deposits that are unprofitable with classical technology, but with our technology will be profitable again. Okay. And finally, ultra depth. So this is an example of the Cooper Schiefer formation. One of the scenarios that we foresee is drilling a very ultra deep borehole to send the robot in pieces down the borehole. This will self-assemble and will start digging underground at very high depth. Okay, concretely, the objective of the project is to develop this bio-inspired modular and reconfigurable robotic miner for small and difficult to access deposits, as we have seen. But we will develop not only the robot, but also the tools. So we have selective mining tools, which means perception to detect the ore and to be capable of having information of the mine structure, and of course production tool, mining tools. Okay, so we will deliver these robotic modules via some access to the mining site, and then perform mining underground, underwater, in a flooded environment. So this is the shape this is under development, of course. So this is the design that we are working with. So you can see here we have this will be one module, and it's going to be heavy duty. I mean, it's going to be a very big machine, like in the range of 0.5 to 1 tons of weight. 20 or 30 kilowatts of power consumption. It's going to be hydraulics and tether. And so many of these modules will join to form a fully functional robot that can perform actual real mining. And this is the drill head that we are developing that will be on the front of the first module. So as I say, it will be a very big robot. For the robotic scale, it's going to be a huge machine, but for the mining machine, it's going to be relatively small. So in mining, we are accustomed to much higher weights and sizes. So we can perform selective and very precise mining in the scale of the mining. So that was the robot, the platform, but we're also working, as I said, in selective mining, which means we should be able to precisely detect where to dig, where is the ore and where is the vein. So we have mid-range geophysical sensors which can map to a certain extent what's behind the wall, what's in the rock, and detect where the direction, the more promising direction where to dig, where the most interesting minerals are. And we also do in-stream elemental and molecular analysis, which means that as we dig, we can analyze what we are digging and decide if it is good enough or not. So which is the minerals that we are extracting with different techniques that, of course, I will not go into the details. But we're trying different fairly advanced techniques. Production tools, so we have to adapt the technology to this scale. So we have considered different technology that classical for mining, drill bit, trick-on drills, hydro demolition, cavitation, even microblasting. We have studied that, and we are currently testing various drill heads that will be mounted on the head of the robot. So the robot and the tools are not everything. Of course, we foresee this system to work in a whole ecosystem. So what we are doing also is actually think about the whole system, the whole mining ecosystem. So new approach for mining strategy, mine design, mining structure, and we studying with simulation the impact, for instance, power consumption, downstream, upstream technology, all the technologies and all the systems that will be supporting the robotics mining in order to have a complete mining system. Okay, so we will do also microeconomic studies and macroeconomic studies, and we also done an inventory of relevant deposits. So where in Europe, which are the sites that could take advantage of this technology. This is the vision. To conclude, So we are working out in a demonstration tool. Basically, as I say, it's a research project. So we don't expect this to be in production in the near future. We'll have a test and real mine test sites towards the end of the project. But we are now working on the demonstration about different technology, perception, production, robotics, self-assembling, artificial intelligence that is connected to the reconfigurability of the robot. So the robot must be capable of understanding what he's doing, if he's doing well or not, or how can it change to have better performance. We're studying, as I said, the mining ecosystem, including challenges, logistics, mineral processing, pumping technology, etc. And we are performing a roadmap exercise about also sustainability and ethical consideration, for instance. And in the long term, like 2050 above, the vision is to have a fully autonomous colony of robots. So there will be in one mine more than one robot working at a time, digging at different locations. That will be totally autonomous, and we will have created a totally new innovation ecosystem. There will be new companies coming in place, possibly small companies, because the idea of this technology is to change a little bit the game. So to change the way mining is performed and seen nowadays. Okay, so that's all for my side. I just want to take advantage of this moment to make some advertising. So this afternoon we will have another webinar organized by the project. It's about novel concept in mechatronics and robotics in mining. And we have also a call of abstracts for the European Geosciences Union General Assembly, EGU, in 2020. About automation robotics for raw materials exploration and production in Europe. So if any of the attendants are interested, you're welcome to join. Thank you very much. Escape.
Yeah, thanks for that. It's very interesting.
Let me stop.
I'll have to stop sharing the screen. Sorry. Yeah.
Okay, sorry for the problem at the beginning.
No, it's fine. It's fine. I guess just to kick off the Q&A, what we like to do is, because both your projects work in the mining industry, but they're also very different. We'd like to ask for the first question, from after watching the presentations, do you have a question for each other? Any curiosity about each other's project, or did anything spring to your mind when you wanted to ask the other?
Yes, I have a question actually. I was very interested about the test sites that you are developing. So because now one of the most close target that we have, apart from the technology, is to find a test site. So we will have a full-scale robot, working robot. So we are now struggling to find a suitable test site. So that was interesting to see that there's a lot of mining sites and a lot of mines and industry that are interested in IT. That's
Yeah.
interesting.
Yeah, actually, yes. These we have, as I said, we have 5 use cases because of COVID since the beginning of our project, because it kicked off in May 2020. So, exactly when the pandemic has started. But hopefully, we will start doing the testing and building. I mean the project is still ongoing, and the next technical meeting, we're gonna have it in 23rd of November, and this is the first technical meeting in presence. It will take place in Finland, so hopefully we will keep doing that and to do it like in presence. Yeah. So we're still in the phase and period of development.
Okay.
Yeah, and the scenarios for each use cases are discussed between partners. So yeah. I think 2 days ago we had a technical meeting regarding the use case scenario of Sotkamo in Finland. Yeah, I do remember the explanation and all the information about ROBOMINERS. If you remember, we had a sort of event or webinars last May. So
yeah, we have a very big, we're very active in clustering and in networking. So I knew about the project. There are many others. And it's good to see how IT and technology is changing a little bit the mining sector that has this image, and I think it's changing, and will, as you said, also will attract more jobs probably in the future, because it's going to be transforming into high tech sector. Now it's seen. I mean, the vision that people has is mine is a very low level, very harsh environment, very low tech sector, which is not totally true, but indeed it is changing. Thanks to all these projects that we are developing, to the push of the EU, we are slowly transforming this field into very high tech. As we have seen in these 2 projects, they're very different, but they go in the same direction, transforming the mining sector into a high tech sector, and that will definitely more interesting in the young persons, and it's good.
Exactly, we are sharing the same vision for the future, and yeah, I think that as I said, as you said also, like new jobs for these for engineers, and they will be more involved in the mining sector, because so far the vision of the industry mining is still the same, but we're trying to change it with time.
Yeah.
Yeah, I have another question for both projects. I'm just curious. Just so both you are creating technologies to better the mining industry. You're creating, as you touched upon it, creating more safety for everyone involved. Do you think ultimately your projects will pave the way to no humans working in mines, or like would that be a goal? Or
In the case of the ROBOMINER, this is the long-term vision. So what we foresee in I say in the long term, like 2050 or plus, is to have totally autonomous mine. I mean, no human in the mine, because this is looks a little bit futuristic. But if you think about Cooper Schiefer, which is several hundred meters, but it depends on the area, but it's ultra depth mining. The idea is to have a colony of, like an ant colony, so a colony of robots mining several hundred meters below our feet without anybody even noticing it, and no humans can go there. One thing that I just mentioned very quickly is about the intelligence of the robots. So what we have seen is the hardware, but we're also working at a very strong work packages on the intelligence of the robots. If you have to work alone with no human supervision or very limited human supervision, then the capabilities of the robot as far as intelligence is concerned, it must be very advanced. So this is actually one of the most advanced things we are doing, is about self-awareness, self-consciousness of the robots. What am I doing? Am I doing it right? How can I do it better, for instance? This is kind of, it's almost philosophical questions, but the robot in the future must be capable of doing this kind of reasoning, because they will be left totally alone. No humans in mind.
I totally agree with Professor Claudio. I believe that our projects, whether Digit or ROBOMINERS or all similar projects working in the domain of optimization of the industry sector, will play a vital role in paving the way to achieve full automated mines that are completely operated by machines and robots, and especially in some areas of the mines with highly potential hazardous conditions. Making use of robots and controlling them from outside or remotely, maybe only our only chance to ever extract minerals in such areas. And we did see some projects who had robots under the water going inside the mines under the water last May. One of the projects. So, for example, these areas cannot be operated, and people cannot work in such areas.
yeah, no, it's very fascinating. It'd be very exciting to see. Will it ultimately lead to the goal of better safety for everyone involved? But just another question, actually, touch upon technology. For digging, you see that, do you think the new adoption of new skills in the mining industry environment will be a challenge? Or due to the nature of yours being a digital platform, it will need someone who has mining expertise, but who also is good with technology. So do you think there will be a challenge in achieving this?
Yeah, thank you for this question. I think the adoption of digital new skills and technologies is doable. Having partners with various competence and backgrounds, we have academic, we have industrial, and we do have also mine operators for the validation, as I said. So on top of that, we have also the collaboration, fantastic collaboration between partners. And we are, as I said, we are doing regular meetings to discuss together the implementation of the use cases scenario. As I said, last one was 2 days ago. And for workers who are not familiar or not capable of using the digital technologies, for example, the smart garment or the artificial intelligence earplug, Actually, this is really one of the expected risks, and in order to mitigate it, we are planning to describe the technical content as generally understandable as possible, and to limit the amount of information to precisely what is needed. So in that way, we can cope with this this, I can say, expected risk, and yeah, we had thought about it.
Oh, yeah, perfect. Yeah. So it also being a digital platform, um, I saw, like, I was reading online, there's sometimes there's an issue around the area of privacy and cyber security. Like, you briefly touched upon it, but what has your project done, or what will it do to, tackle this issue?
Okay, so as I mentioned in the presentation, we will implement this cybersecurity a layer to secure the data, because some of the data, as I said, might be confidential, and we don't want anyone to alert that. So the cybersecurity layer aims to provide communication security on different protocols, devices, and EHS monitoring, and vehicles. So the idea is, so far we're planning to use several IoT devices, for example, smart garment, wristbands, environmental wire sensor networks, and since the data retrieved by these devices can be safety critical for workers and environment, so protecting these transmission or like the data transmission from malicious attempt in causing safety issues is crucial. For example, the smart garment security will be analyzed and discussed in later stage of the activities, and the development of the wireless sensor network security is still ongoing. For that reason, we will do a sort of scheme, topology authenticated key schemes, which is called TACs. And it's a hybrid key management, encryption, and authentication, exploiting the wire sensor network features to provide complete and fast and security solutions. So the work for that is still ongoing.
Yeah. Okay. I just have a question about ROBOMINERS to get you involved in it. So your project's approach is to combine the creation of new mining ecosystems with novel ideas from other sectors. What are these sectors that you talk about?
But actually, there's the technology that will go into ROBOMINERS is basically robotics, of course, because of the robotic platform, artificial intelligence, or detection. We have a partner specialized in geophysical sensor to understand which is the distribution of the ore and to decide, but also, as I said, in-stream analysis. So you have chemical analysis and this kind of stuff. And you are doing the production tools technology. So there's Mountain University Leuven in Austria is specialized in production tools. So they're making lab tests, and they will have field tests with the production tools that they are developing precisely for the purpose, because the scale is smaller with respect to the classical mining machine, and also the kind of sites that we're targeting needs very specific tools. So this is from the technology point of view. Those are the main topics that we are touching. But as I said, we're also studying and simulating the impact of this kind of mining technology in a whole ecosystem. So we are doing studies, for instance, in the upstream, downstream technology, so to pump out in and out the slurry. We are studying new mine geometries, okay, also inspired by marine animals. So because since there will be humans in the mine, the size of the tunnels can be smaller, for instance, and then you don't need to the waters, and also the geometry of the mine can be much different. So we have studied also the mining patterns, mining geometries, and of course we will do some economic study about the impact on surface, so logistic, power consumptions, for instance, and also ethical acceptance of all this technology, which is kind of also critical, because the public opinion when you talk about mining are always like very very critical.
And just a question for like both, just to touch upon circular economy. What do you think of the circular economy approach in the mining sector? Do you think that maybe some areas of the the mining might have some issue adapting the approach?
Mm.
Shall I go first?
Yeah, please.
Okay. So I think that the circular economy approach is taken in Digit project, because in principle the circular economy approach in the mining sector is focusing on highly efficient use, reuse of sensors and recycling, low consumption, low emission, and low waste, and it's a sort of a closed feedback or closed loop process where we have resource, product, renewable resource. And finally, it achieves the optimal production, the optimal consumption, and also minimum waste. So, having said all the impacts and expected impacts of and motivations for the Digit, we do the approach of this is circular economy is adapted in Digit, and we are aiming to expand the material sourcing and improve the resource efficiency. And actually, we have one task regarding that. I don't know if you have time to talk about this task. Shall I proceed?
Yeah, if you
Yeah.
if you like.
Okay, so in order to do to expand the raw materials sourcing and improve the resource efficiency, we will share the acquired knowledge with the raw material information system, RMIS. Which and we will do it through several activities. First, we will harmonize the project progress and results presentation to the RMIS database of the Joint Research Center. And to this effect, initial and progress meetings with the GRC, this Joint Research Center experts, should take place. And regular exchange with RMIS, and these actions are twofold. We will provide the consortium, our consortium, with guidance on terminology, sustainability, information, and best practices gained from the RMIS and from the supporting scientists there. And on the other hand, we will provide the RMIS with meaningful data and outcomes of the project for operation economics, sustainability, monitoring of the key performance indicators, stewardships to circular economy and environmental protection, and best monitoring practices. So I think for the second part of the question, since as far as I know, since the circular economy in all sectors have the same vision, I think that other sectors will not have problems or issues adopting our approach in their sectors.
Claudia, would you like to touch upon the question, or?
Yeah, no, okay. About circular economy, the only thing I can say regarding ROBOMINERS is about the backfilling of the mine. So in our vision, the idea is that we do very precise mining, so everything will be the material we are producing will be kind of pumped out, processed on land, on surface, and then resent back to the mine. So in this regard, we were considering this kind of circularity. So extracting material, keeping the good things, and then backfilling the mine again. And also in this scenario, what we are very focused on is about environmental impact. So the principle is that when the mine operations are finished in somehow, nothing will be left behind. So all the material, all the robots, all that will be taken out the mine, and everything will be restored as it was. So the footprint is going to be, the vision is that the footprint will be absolutely minimal.
Okay, yeah. Thank you for answering the questions. I think we'd like to wrap up the webinar. So again, I would like to thank Claudio and Emel for attending and showing us the fantastic work the projects are doing. And I'd like to thank everyone for watching the webinar. And just to inform you, our next webinar will take place on the 18th of November. The episode will be about textiles, and we've invited Horizon 2020 projects, GREET and Galactos, to help us in that discussion. So again, yes, thank you all for attending. And,
thank you, Robert, for this
thank you.
opportunity.
Thank you very much for the invitation.
Thank you.
Bye-bye.
Thank you. Bye-bye.